Welcome back to our live training session. We're going to be taking a look in this training module at how to calibrate our part throttle cruise area of operation. So this is going to be fuel spark timing and variable cam control. We're going to be focusing heavily on the actual fuel tuning, so dialing everything into our main fuel table. The first thing we need to address is going in and setting up our variable cam target table so that it makes sense for part throttle driving. All K-series will have a pretty similar cam target in part throttle, what's going to work well in terms of the engine response, torque output, and fuel economy. We want to go and set that right now because any changes we make in the variable cam timing table affect our fuel table and require a retune or a touch up on the fuel table. So we want to make sure that we're getting our variable cam targets in order and that makes sense so that we don't have to come back into the fuel table and go through the calibration process again. We're going to be working and taking a look at using the logger software and the Lambda overlay or the O2 overlay. That's going to allow us to do a bit of an auto-tune type of function to dial our main fuel table in. Now, we don't know where the main fuel table values are at, so we might be rich, we might be lean. We have our closed loop correction allowing a large adjustment range for the moment, plus or minus 30% in part throttle and at wide open throttle to allow us some deviation in our fueling, so meaning we can have our fuel not perfect, and the closed loop will clean things up for us. Now, we don't want to rely on that taking a look in, let's say, a shift. If we're making a shift, we have a transient event or acceleration and enrichment event happen, the closed loop will turn off, and if let's say it's taking away 30%, all of a sudden, closed loop turns off, you're making a shift, you're in a transient event, now it's super rich, you have a rich stumble. You might have the opposite, where it's adding a bunch of fuel in. So you're driving around, part throttle, cruise, everything's smooth. It's adding, let's say, 20, 30%. You go to make a shift happen. We have a transient event. All of a sudden, it has a lean hesitation and it stumbles. That's because our main fuel table isn't sorted out. So we want to make sure that our main fuel table is dialed in pretty tight to the desired air fuel that we've specified under our target table here. We've already specified all this in the base map creation. We want to dial our main fuel table into those target air fuel values so that the closed loop is making minimal adjustments. And that'll make more sense as we go through this training module and actually dialing in the table using either a manual method or the O2 overlay method. We'll take a look at both using our log. So we have to actually drive it and start our process. Now, before we do any of this, let's jump in and take a look at our variable cam target table. I want to set that, and then lastly, we'll take a look at our ignition timing and just talk about where we're at and where we set things so we understand the process there. We're going to be dealing with spark timing, but not till later in the training module. Let's go down in here, and we're going to move down in here to our intake target table. This table is going from 0, or in this case 500 RPM to 8,000 RPM, full engine vacuum of negative 14.5 to approximately 0 PSI or atmospheric pressure. Now the values that we place in here are the variable cam target. So this is going to be where the cam rotates to in its position in the table. So depending on where we're at in terms of our manifold pressure or engine speed, we'll have an appropriate cam target that we want to use. Depending on if you're aftermarket cam or OEM cam, I have OEM cams here, we go about setting up the cam target a little bit differently in the overrun or the light vacuum here, area here. I'll talk about what that's going to represent and what you need to do if you have aftermarket cams. Let's go and start to put some values in here that make sense. Now at idle conditions, we're idling here right around 1,000 RPM, and we're pulling right around something like 9.5 to 10 PSI, negative 9.5 to 10 PSI of vacuum. This is going to be where we absolutely want to make sure the table is zeroed out. And in fact, I'm going to make sure it's zeroed out from 1,500 RPM and below across all the manifold pressure ranges. We don't want any variable cam target coming in too low of an RPM. That can create a lot of oscillation and instability in our driving and create surging. So we want to zero it out. Zero cam target means that we have the least amount of overlap and the engine will have the smoothest idle and produce the best vacuum and generally have the most stable idle. So we want to zero this out. Once we start to drive it, we get up to about 2,500, 3,000 RPM. We want to put our variable cam target at approximately 30 degrees. 30 degrees, regardless if you're on OEM cams or aftermarket cams, is going to be about the sweet spot for that variable cam target. It's going to give you the best throttle response, torque output, fuel economy. It's going to be kind of balancing all of those. That's what we want to set for our cam target. Now, once we get into full throttle, the variable cam target is going to change a little bit, and we'll deal with that in another training module. So what I'm going to do is set here from negative 2.5 to approximately negative 0.5 in the table. We're going to just zero all of these out. So make sure everything's zero below 1,500. Make sure everything is zero in the last 3 columns, which will represent our full throttle operation. We'll deal with that later. We're interested in dialing in the part throttle. So I'm going to say here at 2,500 at roughly, let's say negative 9.5 PSI. So in this range right here, I'm going to say everything here up to, let's say 6,000 RPM is going to be set to 30 degrees cam target. Then I'm going to say between, let's say negative 11.5 to negative 9.5, I'll click H. And then here between 25 to 1500, we'll click V. What this is doing is setting a very basic cam composite blend table. This is ideal for part throttle. I'll do the same thing even up at high RPM. We'll do V. Again, full throttle here. Actually, we're going to set this to 0. The last 3 columns, 0. Everything else here we'll set at approximately 30. Now, we do have cam targets at 15. The reason why I'm setting this table like this with OEM cams is when we're in decel or overrun conditions, we're going to be transitioning down into this range right here. So this is going to be about kind of the decel area that I'd expect. In decel, we want to go ahead and rotate the cam back to 0 or no overlap. This is going to improve on-off drivability. So as we come off the throttle, we rotate it back. As we come on the throttle, we start to advance it. Now the problem is going to be, if you have an aftermarket cam, you're going to get into some issues by going in and trying to do this same type of behavior. You have to give a little bit of drivability on-off throttle for the longevity of the timing chain tensioner. Bigger aftermarket cams, as they rotate from 0 to 30, back to 0 again, constantly doing that rotation, it really beats up the timing chain and the timing chain tensioner. So in order to avoid a premature failure, we want to make sure that we're not having the variable cam target do that same kind of movement. So when you're talking about an aftermarket cam, we would set our table something like this. So all of the columns in vacuum would be set the same, and we'd have that same type of target. That way it doesn't rotate in that cam target and beat up the chain tensioner. That's one secret to help keeping the timing chain tensioner and chain intact on a K-series with aftermarket cams. Now you still can have failure, but this minimizes that, definitely helps out. What I'm going to do is revert those changes back. So I'll zero everything out here, 10.5 and below, and then I'm going to go ahead and interpolate here from 10.5 to 8.5. So that was a little bit different than what we just talked about. We want to make sure, again, this is about the overrun area here, so we're going to zero that out. So we have our cam target set. We know that our position was tracking correct, so we know when we were at 0 target, we were hitting the 0 position. We've zeroed all that out. That means that our cam position is correct and the cam tooth decoder wheel was set correctly in that last tutorial. Let's go here, and I'm just going to save this real quick, and I'm actually going to do a save as and save this to our folder as a new name, and we're going to go into our project folder here, and I'll call this cruise tuning so we have that saved. Now we do want to go in here. Let's jump back under variable cam target, or not variable cam target, variable cam table. The programming, we want to go ahead to the minimum duty cycle, set that at 0, maximum duty cycle, set that at something like 90, and then the base duty cycle. This is where we want to have our feed forward value starting at. This is going to be where it starts its control at, and then it's going to use our proportional, integral, and derivative gains to try to trim this base or feed forward duty cycle to allow the variable cam to track to the target. Now, 30 to 40 typically works fairly well for a K-series. I'll split the difference and put it at 35 here. We'll have to test and see how this is going to go. What we want to make sure is before we even do any actual tuning, that if we kind of drive the engine or even free rev it up into the operation range where it's going to command a certain cam target, that we see that the actual and the target are tracking pretty much on top of each other. I've noticed with Fuel Tech, there's always about a degree or two difference there that I can't quite get out. So we're just going to be accepting 1 or 2 degree difference between the cam and the target and the actual. So we'll have to see how that goes. Now let's go ahead, and again, I'm going to save this. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.